My name is Calvin Bacon. I am the product specialist at InstaLOD. And today we're going to be talking about optimizing data for VR, 3D data to be specific. So first of all, we've got some more people joining. Let me keep that open as well so I can let them in. There we go. All right, so first of all, let's have a quick look at what InstaLOD is, just so, in case you haven't heard of InstaLOD ever before. InstaLOD is a 3D optimization software, all right? So it ranges from polygon optimization to UV unwrapping, texture baking, basically taking all of the technical steps that a 3D artist would have to go through and automating them, okay? Everything from batch processing, taking literally weeks of work and automating those steps within a matter of minutes to hours. So it's some really powerful tools that we have at our disposal with InstaLOD. Now, I do want to stress that we're not looking at, or I should say that we are only looking at a fraction of the capabilities of InstaLOD today. Okay, so please keep that in mind. There are a bunch of different features and functionalities that we will not look at today, but I do highly recommend looking at our YouTube channel, for example, where we have a lot of videos covering all of those different features that we are not looking at today. So with that said, let's actually have a look at what we will be discussing today. So here is my list of contents for today's presentation. First of all, we're going to talk about the benefits of VR. Why is it useful? Then we're going to talk about the hardware constraints and the issues that we have with that. And the difficulties of actually optimizing scan data in this example that I'll be showing you today. But in general, just optimizing 3D data and why it's difficult to do. And the challenges we typically have at this point in time. Then we're going to talk about the consequences, and then finally we're going to solve these issues with InstaLOD with a quick live demonstration. So first, let's talk about the benefits. So there are a lot of benefits of VR, and today I want to concentrate more on. First of all, join. Okay. So first of all, I want to talk about the research and the actual hands-on applications of VR. When we're talking about training in VR, if we've got, let's say, an excavation site, right? We're digging out some archaeological items, and that typically is a big issue when that occurs. It delays constructions. If we're currently working on a construction site and we find some ancient relics, the entire construction site needs to be put on halt for weeks or months. Training in VR is also a massive benefit where you can get hands-on experience without accidentally ripping off your arms if you're working on some very dangerous machinery. The point of research and education also really useful. Let's just go through these points bit by bit. So first of all, virtual on-site reviews. Let's imagine we're at a massive automotive company and they want to build a new construction building, right, for the new vehicles, a new line. Well, typically you would have to get the builders on site and measure everything, right? Measure literally every point, every few meters to get an idea of what the land is made up of. Well, these days, what you can do is just scan it, right? So then you've got a scan of the actual site with the elevation and everything, 100% accurate because you've got an actual 3D model of that site. And then you can take that scan, put it into your architectural program and build the building properly so that it matches that elevation, right? And then once that's all done, you can then go into VR and view the building in VR properly. And that is so useful because when you're looking at these scenes in 2D on a flat screen, you don't really get a good idea of what's going on properly. You don't get an idea of the scale and the size of these scenes. Whereas if you're really there and you can look around in 3D, you get a real world idea of what's happening, and then you can make decisions and changes on, or decisions on changes that might need to be made. Is the door going to be big enough for our machinery to fit through? Is there enough space between our different buildings for our vehicles to pass through, and so on. So these are the decisions that we then are able to make because we have a real world understanding of these scenes. Then research or education is another great point. Again, with training, you can train people without having to risk their lives. A great example is dangerous machinery, or putting together dangerous objects like bombs or something. I mean, these things have to be made. You've got to be able to train people on putting these things together first, or actually taking them apart. Let's say we do have a building construction site and they dug out a bomb from the Second World War. We've got to be able to train these people before having dangerous hands-on experience. Anyway, there's a lot of benefits in VR, right? That's the point I'm trying to make here. I'm trying to getting off on a tangent. So we also have a lot of other benefits. For example, if we go back to the archaeological site, we don't have to rent the land for months on end. We can just do a scan of the artifacts that we've dug out, and then we can bring them back to the lab and then do the actual viewing of the archaeological scene in VR without having to waste the time and pay rent and so on. Loads of benefits. So with that discussed, let's talk about the problems we have. The problems with VR are typically the hardware limitations we have. The newest VR glasses that don't require a cable to be attached to the computer are great. They give you loads of freedom. You can just run around in your room. You don't have to be connected to a computer. But the hardware power is quite low, to be completely honest. So you can only render a specific amount of polygons. And if you exceed that number of polygons, you're not going to be able to render 120 frames per second. And this is quite an important number. 120 frames is required, because if we don't render enough frames, we won't be able to get the smooth rendering that we need to feel immersed. If we don't get that number of frames, we can feel sick. Okay, and obviously that is very unpleasant. And I have had that myself. I actually have my own VR glasses. And in the newest games, it's just not cutting it. So we need to be able to optimize these environments so that we can review them and view them properly without getting sick. Right, that is one of the most important things here. We've got a lot of other limitations, right? Not just the actual rendering of polygons, but also the size of textures that we can have, and also the loading speed of these files in general. So we're going to discuss all of this and how we can fix it later on as well. Then the difficulties in optimizing scan data. Now, typically, you typically have two options. Either you do it manually, which is a huge amount of work, right? A 3D artist has to go in, select an edge, decide which edge should be removed so that it makes sense, and remove it. And then he has to do that a ton of times. And this is going to take ages, especially when we've got a really dense mesh like we can see on the image on the right-hand side here. Other issues we have is the input texture size. I have had people send me files with, for example, scan tiles, right? We've got in a massive environment, it gets divided into tiles, and every tile has multiple 16K textures with millions of polygons, right? This is a massive issue. These textures are just eating up memory and slowing down the render. We have to be able to reduce these texture size, optimize the texture pool, to optimize also the file size so that these things load quickly as well. Draw calls are also another issue. The more objects we have, the more materials we need to call, the slower the performance again. These are all aspects that need to be optimized, and doing it manually is an incredibly tedious process. Now, in regards to optimization, there are tools that optimize automatically, but they typically just remove edges in an arbitrary fashion, which isn't good because then important features are neglected, not so important features are maybe maintained, and so on. So we need an intelligent tool to be able to automate this, because manually optimizing and optimizing textures, polygons, it's just not really viable, especially when we start scaling this across these massive environments or thousands of assets. Because if we're working at, for example, like a museum, they've got loads of ancient relics that need to be scanned and optimized and put onto the web for 3D viewing. I mean, you can do it for 10 different models, but you can't do it for tens of thousands of models, at least not manually. It's just not viable. And that's what this fourth slide is about. Scaling hundreds of assets, as I just mentioned, it's just not viable. Scaling over large environments, also not viable, because again, doing it on a single pot, sure, we can do that within a few days, right? But if we're talking about an entire city, not going to happen, right? And then there's also the financial aspect of it, also not really viable if we want to scale. So let's talk about solving all of these issues with InstaLOD, because that is exactly what we're going to do within the next 10 minutes in a live presentation. I'm going to open up InstaLOD. I'm going to load a 3D model, and we're going to make it real-time ready in literally just a few minutes, which would typically take days, if not weeks of work. So first of all, the solutions. Reduce the polygon count. That is something we can do with either optimizing or remeshing. Today we're going to be using the remesher, but InstaLOD has a lot of other features to reduce the polygon count. Then we're going to use a feature called material merging. This is first of all going to repack the UVs, because oftentimes with scan data, you can get UDIMs. Now, whilst UDIMs are nice, they're not really practical, especially for VR. We want to be able to pack all of the textures together. We want to pack the UVs together. Ideally also have new good UVs, because UVs that come from scan data are most often just complete trash. So not something we really want to work with. We also want to bake down the texture size from potentially 16K textures down to maybe a 4K texture or a 2K texture, depending on, you know, the size, the size it's going to be viewed from, and the overall restrictions that we might have for the hardware. We want to fix bad UVs. Oh yeah, this is something worth mentioning as well. We want to generate small output files. Now I've put in brackets here 8-bit dithered normal. This is something I'll explain in a bit more detail later. But basically, normal maps are there to represent surface information within a texture. That means we can remove a lot more polygons, but keep the detail by rendering it in a normal map. Very cool technology. The problem is, though, that normal maps require a 16-bit texture so that it contains enough information so that it keeps and renders those details properly. 60-bit textures are big. Okay, they have a lot of information stored in them, so the file size is big, and that's an issue. 8-bit textures are small. That's great, but they can't contain as much information as 16-bit. I mean, that just makes sense, right? So using 8-bit normal maps just doesn't really work. You get normal map banding, and that's something that's quite visible, and the shading looks weird, and it's just not nice. Now with InstaLOD, we actually have a feature inside of our baker that enables us to bake 8-bit dithered normal maps. And what that means is InstaLOD will actually bake the 16-bit normal map, this full 16-bit texture, but then take all of that information and then sample it down and dither it down into an 8-bit map, meaning we get around 90% of the visual quality of a 16-bit normal map, but with the file size of an 8-bit normal map. And that is amazing. All right, that is, I mean, I use it all the time, especially for web, AR, VR, mobile applications in general. Something where you really just need those files to load quickly. Because to be completely honest, when we're working with for example, mobile applications, if we're just, or let's say web, let's just take the web for example. If we're trying to review individual models on the web, the polygon count is typically really, really low. So the polygons aren't really impacting the file size that much. They're just going to be a few kilobytes to a few megabytes, depending on how many polygons you're working with. But what is really pumping up that file size to be 100, 200 megabytes is typically the textures. And that is where having these 8-bit dithered normal maps really helps to reduce it and keep it within 10, 50 megabytes, whatever you need it to be. Anyway, and finally, we have the option of unlimited scalability because of batch processing. With InstaLOD, we're able to create a profile, which is basically a recipe, right? What do we want InstaLOD to do? We want it to UV unwrap, then we want it to merge the materials, then we want to optimize it, right? We can create these recipes, we call them profiles. And once we've established these profiles, we can save them as templates so that we can use them later, or we can simply use them for batch processing and specify which files, which folders should be processed through that profile. Very nice. So instead of just talking about it and talking about how beautiful it is, let me just show you. I'm going to quickly open up InstaLOD Studio XL. So this is our standalone application. It is worth mentioning that we do also have plugins for other software. So that includes 3ds Max, Maya, Unreal Engine, Unity, Blender. We have a command line application for batch processing. You can also do batch processing directly in the standalone application, but today I will be using our standalone. So with that said, I will grab my model. In this case, we have an FBX file. Let me just quickly import it. So we're just going to drag and drop it into the viewport. This model has around 3 million polygons. It's actually quite low poly, to be completely honest, in regards to what you can get with scan data. I have had people send me files with literally hundreds of millions of polygons, but for the sake of demonstration and to keep this process as fast as possible, we're only working with 3 million polygons here. But still, this is a very impressive demonstration nonetheless, as you will see in just a few minutes. So this model, as mentioned, has around 3 million polygons. We have, I believe, and actually, no, we have three textures, color textures. We don't have any normal maps on the input, just 3 input textures for the color, and they are all 8K textures. Actually, no, that's not true. 2 of them are 8K, 1 of them is 4K. You can see that here, these 3. And we can also see in the material editor, we therefore have also 3 materials. So just to, let's just quickly hide that. So you can see that these materials are applied in patches, right? So if I undo, there we go. Okay, so we've got 3.6 million polygons. I'm just going to hide the background. And this is our scene. So what we've got here is a Turkish Acropolis. It is the Antocia ad Cragnum, if anyone knows it. It's around 2,000 years old, and yeah, this is the scan. Now, this scan has a few problems. Some of them we can fix, some of them we can't, which is just the nature of the beast. Sometimes you just have to work with the data you've got. Now, some issues that are not that incredibly nice are that we do have some texture stretching. That is something we can't really fix in this case, okay? So we can only output, well, let's say the better the input, the better the output, all right? That's just a general rule of thumb that applies to, I think, anything really. But one issue that we can definitely fix is if we zoom in, you can see if I start rotating the environment map, that we've got this very, very chunky shading, right? We've got these triangles, and you can see every single one of these triangles. Because what's happening here is the normals of these faces, they are pointing straight towards each face, and that gives it this very, very hard shading. Now, this is very common with scan data. Yeah, it's just what you oftentimes get. The normals are not calculated properly. So what we're going to do to fix this is recalculate these normals. To do that, we're just going to select the mesh. Then we're going to go to the mesh window up here. And we've got loads of features to prepare and fix meshes here. We can fill holes. We can remove degenerates, non-manifold faces, all that kind of stuff. In my case, we just want to recalculate the normals. I'm just going to reduce the angle threshold to 60 degrees, and then we're going to click recalculate. So now InstaLOD is looking at all of these 3.6 million polygons and looking at the normals and just recalculating them. Now, the reason this is important to do is for the optimizer. It is important because the optimizer takes a huge amount of different mesh attributes into consideration. For example, a normal 3D optimizer is either just going to remove vertices and edges in an arbitrary fashion, which I mentioned earlier is not useful because important details get removed, non-important details or just flat surfaces might not be optimized like we would want them to, and so on. Some optimizers are clever enough to look at the mesh so that they can determine where we have a boundary or a silhouette and try to keep the silhouette, to look as good as possible. But to be honest, even that just isn't enough. because maybe removing a vertex would completely skew the UVs. And then you would get really bad texture stretching on the model after a simple optimization. And that is where InstaLOD really takes this to the next level. If I quickly create a new profile, this is just going to give us access to all of InstaLOD's features. So you can see here we've got the optimizer, remeshing, and so on. The optimizer looks at a lot more features. It doesn't just look at the silhouette. It looks at UVs, textures, vertex colors, the shading, the boundaries, skinning, and so on. And every one of these aspects is taken into consideration before actually removing a single vertex. And that makes InstaLOD's optimizer so incredibly powerful. With that said, we're not going to use the optimizer today. Today, I want to be using the remesher. And again, this recalculation of the normals is still useful because the remesh is going to be able to bake these surface details into a normal map. And I want to make sure that I want the correct shading, the correct surface information to be baked down. I don't want to have some weird chunky shading on the output model. I want to have this, what we see in front of us now. Smooth, correct shading. All right, true to the original. And not some weird artifact shading that we had on the input. So with that fixed, what we're going to do is now use the remesher. Before we do that, let's have a look at what we're actually dealing with. So as mentioned, 3.6 million polygons, quite dense as we can see here. And a big issue is we don't have any back faces. I can turn on back face rendering in the settings here. I'm just using a shortcut, but we don't actually have any back faces. And this is an issue. A remesher will typically always create back faces, meaning we then get twice as many polygons as we actually need, which also means we get twice as many UVs as we need, meaning we get wasted texture space, we get artifacts, and loads of other issues. So what InstaLOD's remesher does have is a powerful setting called ignore back faces. So this is going to do the reconstruction, but it's going to find out where we have boundaries, and it's going to stop modeling there, and it won't generate any back faces in the process. Really useful. Now, the remesher isn't only going to do a full reconstruction, but it's also going to generate new UVs and bake all of my textures together to then bake those into the newly generated UVs. And we can decide how big that output texture should be. As I've mentioned, we've got three input textures, right? One 4K and two 8K. And they are applied to the really bad UVs that we have. I'm just trying to open them. This is quite messy, which is why it's struggling to load. Oh yeah, also my hardware isn't powerful. I should definitely show you my hardware in a minute. I'm not running a super high-end powerful computer. I actually built this computer 6 years ago myself. I'll show you the specs in a minute. Anyway, these are the UVs. You can see my computer is really struggling. Okay, wow, so much for that. Anyway, I'm just going to close it. So, yeah, messy UVs, loads of big textures. So what we're going to do is now, with the remesher, set up some settings, and then with literally a single click of a button, we're going to end up with a low poly, real-time ready model with a single usable texture, which is applied to some usable UVs. Now, let's talk about the settings real quick. In my opinion, the most important setting is the resolution, because this is going to determine which details to model out and which details to model over. So potentially, if I set the resolution here to lowest, we could just model over this entire wall with like a single triangle and bake all of the details down instead. Or if we set it to high or very high, we could have InstaLOD try to model into all of these different rock crevices and, model out all of the details. It's really up to what you want. I'm going to keep it on high. Just to try and get into all of those perfect right angles and get nice crisp lines where we have these walls meeting the floor. I don't want to generate bridging polygons, where it's not necessary. Now, another really important setting is the fuzzy face count. So the fuzzy face count allows InstaLOD to determine how many polygons we need as an output. We as users can determine a maximum count, but the problem is, I don't know how many I need for this. Do I need 50,000 as an output? Do I need 200,000 as an output? I don't know, and you don't know either. You can guess, but that's it. Where this also really comes in handy, the fuzzy face count, is with batch processing, because there we've got even more variables. We might have 500 different models to process. One of them is already very low poly. Maybe one model only has 50,000 as an input. The other model has 50 million as an input, and the other one has 200,000 as an input. How on earth are we going to figure out which to process with what settings? So that is where the fuzzy face count comes in, because it's, again, going to figure out for us what to target. Now, as a rule of thumb, keeping it on normal is going to generate a polygon count usable for real-time applications for PC, console. Setting it to low is going to generate a low amount of polygons, so maybe mobile applications. And the lowest is just going to crunch down the polygon count to the absolute maximum. I'm going to keep it on normal, just because we are still going to end up with a very low poly count nonetheless. Finally, I'm just going to fix something in the UVs, just enable post-process layout to try and fix any tiny UV shells that we get. And finally, we can decide which textures we would like to output. Now, as an input, we've only got diffuse textures, but you can bake out any other textures. I mean, occlusion, curvature, position maps, displacement, and you can use these textures for texturing later. So, for example, you can just slap on some smart materials and substance and call it a day after that. So some really cool workflows we've got here as well. But for now, we're going to keep it simple by baking the normal and the color texture, and we're going to bake all of that onto a 4K map. We're going to click start, let that process, and within the next 2 or 3 minutes, we're going to end up with a low poly model ready for VR. So if you guys have any questions so far, feel free to put those into the chat window, and I'll do my best to answer them while InstaLOD processes. Otherwise, if there's no questions at this point in time, I'm just going to open up my hardware. So this is my task manager, and this is my hardware. So I'm running an i7 6700K. I have overclocked it to 4.6 gigahertz, and I'm running 16 gigabytes of RAM. However, I should mention this is single slot, okay? I've only got a single stick at the moment with 16 gigabytes of RAM. Now, the reason that is worth mentioning is because if you're only running a single stick, it's basically running half as quick as if you have 2 sticks, not just in regards to memory capacity, but also the speed. Having it in dual channel memory, it just runs faster. So this really isn't ideal. I did have 2 sticks, but one of them blew up last year and I haven't bothered upgrading it. So yeah, this is what I'm working with. Now again, the remesher is doing a full reconstruction, right? As if an artist were to do the manual retopology. And I'm sure you guys know how much work that is. Again, on top of that reconstruction, InstaLOD is doing a new UV unwrap for that new mesh, the reconstructed mesh. And it's also baking the textures down into a single 4K map. Now, the reason I decided to bake it onto a 4K texture is because, first of all, a single 4K texture is not an issue to render in VR. And because this is a large environment, I want that additional pixel information, right? Having it on a 2K texture would work, but if we're now walking around this environment in VR, it would get a bit blurry, right? And that is why I want that additional information, a bit more crisp detail, and that's why we're doing it in 4K. Now, with that said, InstaLOD is not actually baking a 4K texture. We are going to get a 4K texture as an output, but InstaLOD is actually baking an 8K texture. And the reason that is because InstaLOD has a setting in the texture output settings called super sampling. It's currently grayed out, so I'm not sure if you can see it too well, but we have a setting called super sampling. And super sampling will scale the texture by 2, 4, 6, 8, whatever you want. And in this case, we have super sampling set to 2, meaning we are actually baking a 8K texture, and then we have this massive 8K texture with all of that information, and then we're taking that and sampling it down to our desired 4K map. Now, the reason we want to do this, or the reason we are doing it, is because we are going to end up with a more accurate, a more detailed 4K texture than if we were to just simply do a normal 4K bake without super sampling. Okay, so considering that we're doing a full reconstruction, UV unwrap, and an 8K bake with 3.5 million polygons as an input on my old computer within, let's say, 3 minutes, we're already at 90%. Well, that's incredible. Now, again, imagine if we were to need to scale this, if we were to need to automate this across thousands of assets. Well, That's fine. If I'm happy with this profile, if I'm happy with these settings, I'll just take this profile, I'll save it, and then batch process it either through the command line or through InstaLOD Studio XL. And then I'll just go and grab a coffee, right? Half an hour later, an hour, 2 hours, how many ever, models you're processing, however big they are. Well, you just come back a few hours later and it's all done. You've got all of your models real-time ready, just like that. And here we go, from 3.6 million polygons to 27,000. Just like that. To be honest, this is probably a bit extreme, all right? I am aware of that, but it is possible, okay? And if this is what you want, if this is what you need, well, there you go. If you want to have more polygons, sure, do that. That's not an issue, right? Just set the fuzzy face count to high, to highest, or if you want to, set a maximum count. No problemo. But the fact that we're down to 27,000 with this visual quality, I mean, you can see that the shading across these rocks is all still there. It's not in polygon form. You can see that we've modeled all over these rocks, but it is still there in the texture, in the normal map, right? Here we've got these UVs, just a few big shells for the entire complex scene, right? That is definitely worth mentioning. Very nice to see this. The color texture, again, 4K, we did bake it out. That is what we wanted. And the normal map. And the normal map contains all of that surface detail. You can see the rocks on the walls. Everything is stored inside of here. So, oh yeah, also worth mentioning, no back faces, right? We did not generate any back faces in the process. Okay, so we can see here, this entire process took 194 seconds. That's just over 3 minutes. I would say that that is quite a success, considering that this would probably take a lot more than 3 minutes when you're doing it manually. I think we're talking about days, if not multiple weeks of work. Yeah. So I think that pretty much summarizes what I wanted to show you here with this presentation. Let me just go back to my slides, because I do have a summary slide here. So first of all, the first issue that we talked about was the hardware limitation. Well, that is no longer a problem because with InstaLOD, we are able to optimize our 3D models. All right. The draw calls can be reduced. In this case, the input model was a single mesh with 3 materials. So altogether, we only had around 3 or 4 different draw calls, nothing too major. But if you did have hundreds or thousands of different scan tiles or just loads of different individual meshes, you can drastically reduce the draw calls to single or just a handful of draw calls with material merging or with remeshing, right? You just end up with a single model. The texture pool has been optimized as well from 3 8K or 2 8K, 1 4K texture. We are now down to a single 4K texture. We could easily bring it down to 2K as well if you want to. It's all down to what you desire. So the texture pool has been optimized as well. Then the second issue, the polygon constraints. Again, that is a hardware problem that we have now, we haven't fixed that it is a limitation. We know that is a limitation and there's nothing we can change about the hardware limitation, but we are able to optimize our data without losing any necessary quality. I mean, in this case, we did do an incredibly drastic optimization. So yes, some detail has been removed, right? It's just, right? When you're optimizing, that's what happens. But the fact that we have this incredible good quality with that ridiculous low poly count is incredible. Obviously, you could just go high with a polygon count. It's all down to what you want. But again, this polygon constraint isn't an issue anymore. We can create great looking models and match the target count that we need. Then the issue number 3, manual labor. Well, that's not an issue anymore because we're not doing any manual labor anymore. All of these tedious processes of UV unwrapping, reconstructing meshes, texture baking, all of that, hours of work, all put down to a single click of a button. Then issue number 4, the file size, also not an issue anymore. Again, we are able to optimize the polygons, which removes polygons, meaning removes data. The output mesh, therefore, is smaller. The textures, also optimized. If you want to go crazy with the file size reduction, you can also use 8-bit dithered normal maps. That is, let me just quickly show you that. In the texture output, you've got the option to determine how you want to bake your textures. And for the 8-bit dithered maps, you would simply change this 16-bit export format to an 8-bit dithered. But you can also bake out in different formats. But again, I'm a big fan of 8-bit dithered. So that is how you would then reduce the file size and how we have done it now. And then finally, the last issue that we talked about earlier, scalability, and that can be solved through batch processing. So again, if that is something we want to do, we can now take this profile. In this case, it's a very simple profile. It's only got one single entry. It is using the remesher with these settings and these bake settings. And if this is what I want, then we can simply save it, save profile as, and then we can call it test. And then you can either open the command line and batch process it through there, or you can do it directly in the standalone application by just opening this file, run profile into the pipeline, and then we get a proper user interface. And you can just drag and drop your files and folders or load them here, however you like, and then just click start, and then whichever profile is currently loaded then gets processed through. So very easy for the user, no more manual work. So yeah, that pretty much sums up my presentation. So again, if you guys have any questions, please put those into the chat window now and I'll do my best to answer them. So we've got one question already in the chat window. How big can scenes be? Is there a polygon limit? That is a very good question. Now, typically with optimizers and remeshes, yes, there is a limit. That is typically around 3 to 4 million polygons. And that's a problem, right? Especially with scan data, because scan data typically starts at 3 to 4 million polygons, meaning that you wouldn't really be able to actually process these massive files. Now, the great thing with InstaLOD is we don't have a limit, okay? The software itself does not have a limit. If you want to process 500 million polygons, the software can do it. You will simply need more, well, a stronger PC. For InstaLOD, you typically just need more memory, okay, to store the information while it's being processed. So with my computer, with my 16 gigabytes of RAM, I can maybe go to like 30, 40 million polygons. Depending on how big the input textures are. If I don't have input textures, if it's pure polygons, I might be able to go higher. You might want to have more memory, 32 gigabytes, 64 gigabytes. If you're trying to process hundreds of gigabytes of, hundreds of millions of polygons. Well, yeah, you could do gigabytes of data as well, of course. But yeah, so in theory, there is no actual hard limit with InstaLOD. You just need to make sure that your hardware is capable of holding and storing that data while it's being processed. Then another comment. First of all, thank you for the kind words, Felix. And then the question is it possible to optimize, reduce different areas of a mesh to a different degree, e.g. by using masks? That is a really good question, and the answer is yes, that is possible. So let's just use this optimized mesh as an example. Let's say that I want to optimize half of it more than the other side, okay? So if we want to do that, we would simply use, quite literally, a mask. We just use vertex colors. Okay, so in the vertex painting mode, which I can access by selecting this paintbrush, what I want to do is select the mesh, and then we're going to begin painting. So I'm going to paint with a blue vertex color channel. So the green channel is set to 0, the blue channel is set to 255. Let's just set the radius to 10. Paint one side blue, the other side we're going to keep black. And then we're just going to click commit. Now with that done, we're going to use the optimizer. We're going to optimize to 50%. And then what we're going to do is tell InstaLOD that I actually want to use those colors that I've just painted. And we're going to do that in the advanced settings in the optimizer weights. And here we're just going to use the color set index. So this is the index of the color set that I have just painted. And that tells InstaLOD that these colors are important and we're now going to take them into consideration. So we're going to click start. We're going to use the processed scene. We're optimizing to 50%, and you can see from 27,000, we should end up down to 13,500, 14,000 polygons. There we go. And half of it is optimized. The other half is not. So you can do this to, paint details on, I don't know, cars or screws or whatever. There are all kinds of applications for this. Yeah. So any other questions? And for anyone who's a bit short on time, first of all, thank you all so much for sticking around. I really appreciate you taking the time. And yeah, again, you can find out more about InstaLOD if you go to instalod.com. We have a YouTube channel with loads of videos that explain all of our different core features in more detail. And yeah, you can also try InstaLOD for free. So just reach out to us and we'll get everything set up for you. Another question from Stephanie. Can you copy paste a additional area into the existing one? What exactly do you mean by that? Do you mean by actually importing a separate file into the scene? Or what do you mean? Because I can do that, but I can also just duplicate this scene, and then I've got two of them. Okay, so yes, I think the question was importing another mesh into the scene. And that is absolutely possible. Let me just grab my data, InstaLOD, test data, and we're just going to import a different model into the scene. Yes. So the answer is yes, we can absolutely import multiple meshes into a single scene. Yeah. Any other questions? Does InstaLOD work locally? That is a currently incoming question. What exactly do you mean by that? So it doesn't work through the internet, if that's what you mean. Like, yes, I am processing it on my local computer. No data is being sent anywhere. It's not being processed externally. Yeah, maybe you want to clarify what exactly you mean by that, Rania? We do also have a tool called InstaLOD Grid, which allows you to set up a server so that, for example, in an organization, if you've got hundreds of colleagues, you don't have to actually process your data locally. You can send it automatically to the InstaLOD Grid server, which then processes it to worker nodes. So these tasks get sent to external processing nodes, and then once that's processed, you can then download it as a user. So there is that option as well. Then another question. First of all, thank you for the interesting presentation. Can CAD data be imported for direct optimization, or is a conversion to polygon-based formats necessary beforehand? No, so CAD data can be imported directly. So I actually have some native CAD files here. I'm just going to drag a CATIA file in my case, but we can support loads of other files, SolidWorks, STEP, PDC Creo, all kinds of different formats. And we can then decide how you want to tessellate it. So we've got a really high quality tessellator, and then there you go. You've now got yourself some polygons to work with. So really powerful stuff. Yeah, so STEP files is also supported. What else do we have here? What about optimizing files other than scan files for VR? Is the workflow drastically different? No, not at all. So the workflows are pretty much the same. So if I want to do a remesh on this model, that's absolutely possible. Let me just quickly tessellate it a bit finer. Fix the shading here as well. Retessellate it. There we go. So even after we've imported CAD files, we can still retessellate. I'm just going to fix, or actually set up some materials. So we've got something nice to look at. Apply that over here. And then what I can do is just remesh this. So we're going to go to the remesher. We can use the exact same settings that we used earlier. I'm actually going to reduce the resolution to normal because that's fine. I don't need ignore back faces turned on. We're actually just going to change the algorithm of the UV slightly just to give us a better unwrap. And then we're going to bake the roughness and metallist textures now as well, because we have now included these different material parameters. But now with a single remesh, I can end up with a low poly rim in this case. So from 80,000, let's see what we end up with. So then another question is coming in. Is a web service available on the internet? Not right now. As far as I know, it is in discussion, and I think we've been wanting to do this for many years now, but it's not available just yet. I think we're doing some tests at the moment, but I'm not totally sure when that will be available. With that said, we do have InstaLOD Grid, which is a local server network that you can set up in your own intranet. So it's not in the internet, but in your local intranet. Hope that answers your question. Another question is, I can see that you're running InstaLOD on Windows. Is macOS supported too? Yes. So macOS and Windows are both supported. Linux not yet, but I believe is also a work in progress. Another question is, you spoke briefly about additional functions and you mentioned the possibility of filling holes. How exactly does your software deal with this? Is there some intelligence behind it, like repeating patterns, etc.? So first of all, regarding filling holes, we are currently working on an algorithm that is going to fill holes differently than we're doing it right now. At the moment, we are limited to filling holes that are based on boundaries. Okay, so an actual non-watertight mesh. So for example, here with this rim, this is actually not a hole, even though you would say that this is a hole for these screws. For us, in theory, yes, it is. This is a hole. You might want to close it. But with our fill holes feature, this will not be filled because this is not a non-watertight mesh. It is actually closed, right? We've got polygons going inside of here and so on. This will not fill the hole. Fill holes will fill a hole if, for example, this triangle over here is missing, right? Then we actually have a open hole in the mesh, and then fill holes will close it. So it's looking for boundaries. But with that said, we are currently working on an algorithm that will find loops. Okay, and loops is what this is over here. This is a loop. And then that feature, and it looks really promising, will be able to close off these holes. So yeah, it's not using AI, any of that. Just, well, the upcoming one will be just using some really clever algorithms to find these loops. Yeah, then in regards to the other functions, I assume you're talking about the different features. So today we've talked about remeshing. We did have a quick look at optimizing. So the optimizer is, in theory, pretty straightforward, right? It just looks at the same mesh, it takes the original mesh and it just removes edges in a really intelligent way, but that's basically what it does. So UVs, textures, everything, you know, vertex colors, all the metadata, everything just stays the same way because it's the same mesh, just optimized. Remeshing, as we've seen today and as we've seen here, does a full reconstruction, right? So super low poly, and yeah, you know, that's that. This remesh took really long because we've been baking 8K textures. Normally I would do it on 2K and then it goes much faster. That's normally it's done within like a minute maximum. But because we've baked 8K, it took so long. But you can see, right, even with like a 90% reduction of this remesh, we've got really good looking results. Let me just change the environment map to a studio light so we can appreciate the shading better. So that's that. Yeah, the remesh again does a full reconstruction, generates UVs, fixes all of the broken geometry you might have as an input, and so on. Then we've got imposterizing, which generates the illusion of 3D geometry with really simplified meshes. Material merging merges materials, merges textures, creates texture atlases, packs all the UVs together, and ultimately reduces draw calls. Occlusion culling is there to remove geometry that is not visible. So automatic interior is one of the modes, which removes polygons or objects within a scene. So if you've got a motor with loads of parts on the inside that you don't need, if you've got a vehicle with loads of parts on the inside, if you've got, you know, you get the idea. It removes the interior. Then you've got camera-based, and this allows you to set up your own cameras, and whatever is not visible by those cameras simply gets removed. So I've used this for like cave environments, when you kit bash your scenes together with loads of rocks, then you've got loads of intersecting polygons. So what you can do is just create your own 360-degree camera rig, duplicate it around the cave, use camera-based, and then any polygons that aren't visible are gone. Or, I mean, you know, it's all down to the imagination on where you want to apply this, but there are loads of use cases. And then UV unwrapping, UV packing, and the mesh toolkit. And the mesh toolkit is just, well, the mesh toolkit features here are all the same as up here. And the reason we have them in the mesh toolkit and up here is because the mesh toolkit allows you to do it in chain reaction processes. Because maybe you want to first do a vertex weld, then you want to combine meshes, then you want to do a UV unwrap, and then you want to optimize meshes. Now, at this point in time, they're all running in parallel. So we're going to get 4 output meshes. one that has been vertex welded, one that has been combined, one with UVs, and one that has been optimized. That is not what I want. What we can do is go to the profile settings, enable previous output as input, and this is going to therefore enable this chain reaction process. And that is why we have the mesh toolkit, so you can use these cool features in these chain reaction processes, and then in this case only output the last step. Of course, you can also output multiple steps. That would be useful if you want to maybe generate multiple LODs. So optimize 2, optimize 3. These would then be our potential 3 LODs that you might want to output. As an example, right? I hope you get the idea of what this is, how powerful this can be. But this allows you to generate these complex mesh operation chains. So another question. Yeah, that one's been answered. Great to hear about the macOS support. Also, you mentioned there are integrations into Unity and Unreal Engine 4. Are these available for testing too? If so, how can my team try them out? Yeah, so the standalone and all of the plugins are available for testing. You can try out InstaLOD using a free trial. You just have to reach out to our team. Let me just quickly open up. If you go to instalod.com, there you go. You've got a big pink evaluate now button on the top right hand side. If you fill out the form, someone in our team will reach out to you very quickly and make sure that you are set up. And then you can try it out with your own models and see how well it works on your own scenes. And I think that's what it's all about, right? I can talk as much as I want about how amazing this is, but unless you guys try it out on your own models, I'm not going to be able to 100% convince you. And that is why I do highly recommend trying it out yourself. See if it works for you. And I'm convinced it will. If you have any questions, we are always there to help. If you have questions on the software or questions on how to process your own meshes the best way, I am also a person of contact in that regard. You can book an introduction session with me, a tech meeting with me, and I'll try to, help you in any way that I can. So again, if you guys have any further questions, please feel free to put those into the chat window now. Otherwise, thank you so much for taking the time. I really appreciate, the time that you've now taken. I know that this presentation officially only takes, I think, half an hour, and we're almost an hour in, so I do appreciate that. And yeah, cheers for sticking around. There are some more questions coming in, so if you want to hear me answer those, please feel free to stick around. So one question is, how does InstaLOD deal with shadows in scan files? That is quite an interesting one. So InstaLOD actually has the capability of delighting. This is actually quite powerful. Let me just quickly open up a model here. All right, so what I'm importing here is a pineapple, or a scanned 3D pineapple. And scanning never really, well, even when you've got a really good lighting environment, which we can see this model was lit very well when it was scanned, it's still not 100% perfect. Okay, we've got some ambient shadows, but inside of these crevices, we've got some shadows inside of, between these leaves and so on. So what we can do is use the remesher, and then with the baker, we can remove these shadows, remove highlights, flatten the texture so that we can relight it in our own environments, which is really nice. I'm just going to create a new profile. I'm going to use the remesher, but I'm going to set the resolution to lowest just to speed up the process because I want to show you the delighting and not, the remesher right now. So delighting is available in the texture output window. Enable delighting. We're just going to bake it onto a 2K map. Yeah, I think that's all we need. So 1 million polygons as an input. Reconstruction, again, UV unwrapping, all the same stuff we've talked about earlier. And in this case, including delighting. And then another question from Jacob regarding the integrations. What other integrations were there apart from the game engine ones? So that was, the Blend integration, the 3ds Max, and Maya. And then obviously Unity and Unreal Engine as well. So yeah, if you're using Blender, you can absolutely use our Blender integration as well. Oh yeah, by the way, it's worth mentioning InstaLOD uses the CPU, and you can see also how InstaLOD uses every single core to the absolute maximum extent. That is beautiful to see, especially considering that a lot of software out there only uses like 2, maybe 3 cores if you're lucky. So being able to utilize all of the cores wherever possible is very nice. And here we go. Previously, where there were black, shadows in the crevices, we didn't make them gray. That is worth mentioning. InstaLOD knows what color needs to be there, and then gives you the nice vibrant green that should be inside of there. So if we now go to a strong shadow environment, we can see that if the light shines right into these crevices, we obviously shouldn't have shadows where previously there were shadows. So yeah, I hope that answers that question. Okay, so I think we're also slowly coming to the end of this presentation. I think we are able to do an hour, and we started almost an hour ago. So again, thank you very much for sticking around. If you don't have any more last questions, I highly recommend going to our website, instalod.com. Try out InstaLOD for yourselves, right? Please request an evaluation, see if it works for you with your own models, and yeah, see how we can help you. Again, we are there to help. So if any questions do arise, please just reach out. Otherwise, thank you very much for sticking around. I do appreciate you taking the time, and I hope you have a great day. If you enjoyed this video, drop us a comment below and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all of the links in the video description below. Thanks for tuning in, and I'll see you in the next one.